So the next talk will be by Fred, and she'll be talking about this package that they developed called revelio. And she just told me now that it's about facilities to help data scientists take their models into production. So please welcome Fred.
Hi everyone, I'm Fred, and I'm going to tell you a bit about revelio, what it is, and how it can help you create data science APIs using magic and a few lines of code. First of all, I'm just going to introduce myself a little bit. That's me, more or less. I'm told I have a bit of a ginger tinge. I don't see it myself, but here you go. I'm a physicist by training, so I did my undergrad in theoretical physics at Durham University, and then I did a PhD at Imperial, again in physics / chemical engineering, where I worked on simulating water flows through membranes, for the application of water desalination, because we all want to save the world in some shape or form, right? So I did that there. I learned Python in my undergrad, just doing the standard numerical methods thing, where you solve equations numerically and things like that. And during my research, I mostly used that to read in data, do some averaging on it, some basic model fitting, and also to do some plotting. So I did some cool-looking plots like the one on the left, and some boring-looking but published plots like the one on the right. There, however, I just wrote code. It probably didn't look particularly nice, not going to lie, but it did its thing. During my PhD, I also took some time out to do an internship and work part-time for a while for Shazam. So there, I used Python partly to automate some things and also to mostly gather some data, and I did that using doing some web scraping or creating external and internal APIs. That's also the first time I was exposed to kind of creating some open source code. So if you're interested in how to read in app reviews from both Apple and also Google Play reviews and doing some translations and things like that, feel free to check out the Shazam GitHub, and if you're really interested, then you can read my blog on how to detect when something's wrong in your app. So this is, like I said, where I first did some open source code work, but still, I wouldn't say my code was the highest level. After my PhD, I did the Data Science Fellowship at ASI. So for those who don't know, ASI is both runs the fellowship, so it's a data science fellowship mostly for people coming from academia, but they are also a data science consultancy, and they also create Sherlock ML, which is a data science platform. So it's both for developing models, but also for the deployment process. And during my fellowship, I worked on the Sherlock ML team, developing revelio. So this brings me back to what I'm presenting now. So this is mostly a tool that's aimed at data scientists to help them do the deployment of the data science process. So this is Hermione. You can barely see her, but it's Hermione. For those of you who are not obsessed with Harry Potter like me, Hermione is a very smart girl, which is why she's a data scientist. The majority of her work really is about collecting the data and then creating good data science models that give you insight. So the first part is mostly around gathering lots of data, combining data sets, cleaning the data, making sure it's in the right format, and so on and so forth. And the other big part of her work is finding a good model that gives insight into the data, or makes predictions that are useful, especially, for example, in business, making predictions based on existing data if you're given new data. However, that's not everything that's needed in the kind of data science pipeline. The final step is the deployment step. So basically, taking this trained data science model and bringing it to the people. So by the people, I mean it could be Hermione, who just regularly wants to use her model without messing with it. So she's trained her model, it's fine, it works, and she wants to regularly use it. It could be someone else in the same company who then wants to use the predictions from that model in some shape or form. It could be a client. So if you wrote the model for a client, it could be that the client just wants to send the model some data without knowing how the model works and use it. It could feed straight into some other application, so it could feed straight into some other software that uses the prediction of the model, and so on and so forth. This is like a sample deployment pipeline. So what you need really is a trained data science model, and then you need an API which basically connects the model to the outside world over the web. For that, you need a URL to access it, and ideally you want some authentication and some security around the data that you send in, and so that not everyone can just use your model. So if you have software like, for example, Sherlock ML, some of the bits of this process are done for you. So here, for example, Sherlock can help you create a nice URL that you can use, and it also deals with a lot of the security, ensuring it's got a secure connection and there's proper authentication and so on and so forth. But you still need to write a bit of code to actually create this API. Now when I talk about data science API, the basic process is this. You want to have some data, so take the data that you have, you want to send it to the model using what's called an HTTP request. Then the model will read in the data, make a prediction, and the prediction is sent back in a response. So this is kind of the basic process that you have to write some code for. Now, this is not really typically what Hermione does, because she deals with the cleaning of the data and gathering the data and also creating a model. So typically she asks her friend Harry, the data engineer, to do this for her, because this is really more his expertise. He knows about what goes on under the hood, so to speak. He writes really robust code. He definitely knows how to make sure it doesn't fail very often. However, what happens if Harry's not available? Unfortunately, he had to jet off on a little adventure and save the wizarding world from an evil wizard. So Hermione's kind of left to her own devices. But like I said before, Hermione is quite smart, so she knows how to help herself. So this is a sample data science API written using Flask. So as you can see, it's not actually very long, so it is quite simple. So I'm just going to break down a little bit what you need for a very basic data science API. The first thing we do here is we just read in the model. So Hermione's already trained a model and stored it somewhere, and here we're just reading it in this case from a picker file. The next thing you need to do is you need to initiate a Flask app. And finally, this is the bit that actually does the work. You create a predict endpoint, and here you can see that the data is read in from the request. Then it's fed into the model. That makes the prediction, and the prediction is returned. So this is basically like what I talked about before. You take the data in, the prediction comes back out. So that looks pretty easy. It's not very many lines of code, so why am I making such a big deal about this? It's simply that what happens if something goes wrong. And we all know in the real world things go wrong more often than not. And what happens if you just write a very simple short code like that? Things that could go wrong, for example, are if there's simply just a typo somewhere in that code, if the model doesn't actually work the way you expect it to, if the connection isn't working properly, or if the data that you send in is not really compatible with the model, so the model doesn't know what to do with it. If you just write the short code that I showed you, the error messages that you get are not very helpful. So I just put down some of the potential texts that you might get, which don't really tell you specifically what is wrong at all. So this is my favorite, the 500, the internal server error. It tells you something is wrong with the server or with the application, which tells you exactly nothing at all. So you're going to take a long time if you want to figure out what's actually wrong. The reason that this is bad is because it makes it pretty hard to debug and pretty hard to use. So Hermione doesn't really know where to start fixing it because she doesn't know what's wrong. As a user, you don't know if the problem is with the app itself or if it's what you're sending it that's wrong, so it's not a very good user experience. It means that the longer it takes you to fix things, the longer it takes you to use things, you're losing value because you can't actually use your predictions in some kind of business sense or to drive decision making and things like that. And the worst thing is obviously that Harry has to come back and stop fighting Voldemort and has to fix it. So that's obviously not great. You want the data scientists to be able to do this quite easily if they need to, even if they don't have a strong engineering background. So this brings me to Revelio. This is the code that you would need if you want to use the Revelio package. And I'm going to break it down just like I did before. So the first step is the same as before. You read in the model from, in this case, a picker file, but could be in other ways as well. The next step is that we require, well, we don't require, but it'd be useful if you had some sample input, and I'll come back to that later to explain why that is useful. And then finally, you just initiate the app, but this time you initiate it just by using revelio. So it's just that one line that you do. And the rest is all contained within that. The advantages of this that I'll talk about a bit more later is that it gives you much better errors, and it gives you some documentation, and it basically means that it's a lot more user-friendly, and it also means it's a lot easier to fix if something's wrong, both from the data scientist perspective and also from the user perspective. That means you save time, and also you don't hate your life quite as much. So the endpoints that you automatically create and expose using a revelio app are these ones. So the first one is the one that I showed you before, the predict endpoint, except we don't just do the prediction, but we also perform some input validation before. So we check first if the input that you sent is in the right format. We also have a health endpoint where you can just check if the API is up and running, basically. You just check, does it work? In principle, yes, no. So you can see if there's a connection issue or not. We also create some documentation, so that's good to help the user so that they can look at what kind of data they should send. And finally, there's a metrics endpoint, which will return recent API calls in a given time frame. And I'll talk a little bit more about some of these. The other thing we do is when you first initiate the API, we check if the model is actually the right form. So we expect the model to have a predict method, as you have with most, like with the scikit-learn classifiers, you have a .predict method. And if this doesn't exist, so if you can't actually use the model to make predictions, then we'll give you an error. So that means you'll know before you even give the API to any users that something's wrong, and you can fix it before anyone tries to use it. And again, the error will be quite specific. It'll tell you the model doesn't have a predict method, so you know what's wrong. The big thing is really that we do is the input validation. So I said before that it'd be good to have some sample input. This is because we use that sample input and something called marshmallow to validate the input. The way this works is basically we use the sample input to create a schema. So that's essentially a checklist for the input to make sure it's in the right format. So at the moment it's implemented for NumPy arrays and pandas data frames, and for arrays it'll check if the array is the right length that you require and the right data type, and for data frames it checks if it's got the right number of columns, the right column names, and if these columns have the data type that you expect it to be. And if that's not the case, then it'll raise a validation error, and that will have quite a specific error message. So I can show you some examples of what happens if you send the wrong input, and then you can see how specific it really is. For that purpose, we've just used the Titanic dataset and a simple model that can predict whether or not someone survived. The input it expects is a pandas data frame with these columns that are listed here, so those are 7 columns. And now I'm just going to make some bad requests to the API to see what comes out. So the first example is when we're missing a column. So I've just dropped the p-class column, so it doesn't include, in this case, fairly vital column to make the right prediction. And here's the output. So the first thing you see is that the error already tells you that the input validation failed. So this is already much better than just server or application error. You already know it's something in the data that you've sent. Now, if we look at the specifics, you can see that something in the data, something in the p-class column, and it says missing data for required field. So this tells you that the column p-class was required and that it's not there. So as a user, you already know, oh shit, my data is missing the p-class column. I should fix that. It's clearly not a complete data set. The next example is where you have the wrong data type. So again, using the p-class column as an example, that is meant to have integers of values 1, 2, and 3. But we've just replaced it with a string. So again, you get the input validation error, but you also get specifics about what's wrong. So again, it says p-class, and it not only tells you that it's the wrong type, but it also tells you what the expected type is. So you know it's meant to be an integer, and it clearly wasn't an integer before when you sent it. I also mentioned documentation. You can't really read it very well there. But we use that schema, that checklist that we created for input validation, we use that to actually create some documentation automatically. So if you look at the documentation, you'll see what, in this case, what the columns are that are expected, and for each column, what the associated data type is. And you can also, it's compatible with Swagger, or I think OpenAPI is called now, and you can look at that in a slightly more legible format as well, if you like. And that's very helpful for the user, because the user doesn't have to ask the data scientist first what data is expected. They don't have to do a trial and error type thing, but they can actually just look at the documentation, which will tell you what you're meant to send in. I also mentioned the metrics endpoint. So this returns recent API calls, and it doesn't just tell you when they were made or that they existed at all, but it also gives you some additional information. So one thing we do is we time the input validation and the prediction step. So this is especially helpful if you notice that maybe the predictions take a really long time, or longer than you'd expect them to take. So you can maybe look into making your model more efficient if you realize that it's taking too long, or if the validation takes a long time, you can try and make the process a bit more efficient. The other thing you can do is you can just monitor the usage of the app and see when there's errors. So here we just made a simple dashboard where you can just look at a given API, you can look at a time-date range, and you can see what kind of API calls were made. So you can display that graphically if you want, or also just as a table. And here, for example, you can break it down by endpoints, so you can see, for example, if you see a lot of people looking at the documentation, they're clearly not understanding what they're meant to do. If a lot of people are querying it at a certain time, you might know that there's problems with and then there's also errors at the same time. There might be overload problems and so on and so forth. You can also break it down by response code, so if there's errors or not, or you can look at what authentication key was used. So you can maybe figure out who's having particular problems with the API, and you can maybe help them, and you also know who's using your API. A few other good things is first of all, it's Python 2 and 3 compatible, so if someone hasn't switched over, you can use it on both. I'd like to say it's quite well tested. At least we've written quite a lot of tests, which was fun and not fun at the same time. It's going to be open source hopefully soon, and because this is really a product aimed at data scientists, there's a few extensions we have in mind. So one thing, for example, would be looking at enabling data scientists to do A/B testing using the API, so that the user doesn't really know what's happening, but you can maybe give it two models and implement A/B testing and things like that. So this is really written with the data scientists in mind. So I hope I've shown you that this is very useful, that it's useful for the data scientists because they can create an API and deploy their model quite easily without really too much effort and without having to know what goes on under the hood. And it's also good because that way Harry can go save the world and also do all this normal work. And hopefully this has been helpful, and feel free to come chat to me afterwards if you've got questions. Thank you. Yeah. Okay. Sorry, this is very short. I talk fast.
Okay, that was a really great talk there from Fred. Do we have any questions? Got time for a couple. Yes, Neil.
Thanks very much for the talk. It's great. Just a really quick question: is it able to deal with long-running queries? Can you
not currently, but this is also something that obviously, because we know that the prediction could take quite a long time. So at the moment, it's still in the early stages, but obviously that's something that we'd want to implement.
Hi, thank you for the talk. I just had a question. When you install this, do you install it alongside the Flask application, or does this replace the
So Flask is a requirement of the package, so it would be installed automatically. So it's because it's all based on Flask. So when you install revelio, it would install Flask.
So you wouldn't have to write any Flask after you invite?
No. You literally, the one line I showed is literally all you do for now. The other thing we wanted to do is maybe make it customizable so that you can add your own endpoints to it if you want to, and things like that. But at the moment, this is what it does.
Any more questions? I've actually just got a quick one, because we had some people talking about Sherlock ML last time as well. Is there any sort of, because I know it's ultimately a paid service, I think. Am I correct in thinking that? So, but are there any ways, because I mean, I know it's trying to make, well, from what I understand, it's trying to make this sort of deployment of data science models easier. Are there any ways, I mean, I know you're saying that this will soon be put into open source, but are there any ways that sort of people can have a go and just trial it out and get some tutorials about, just to try and get their foot in the door with using it?
I mean, Sherlock, there's a free trial, I'm fairly sure. Is there a free trial?
Yep.
Yeah.
Okay.
So, yes, you can use a free trial. And obviously, if the package is open source and you just want to use it by yourself, you can just download it once it's out there and use it in your own context. But, yeah, Sherlock also has a free trial, so if you want to try it out, go for it.
Thank you. Any more questions? Well, if not, let's thank Fred for the talk.